Hello, here we are at the Finite Link channel, and now we are studying about the VLANs. As a reminder, VLANs are created at the layer 2 to reduce or eliminate the broadcast traffic. VLANs can break your network into smaller networks so that devices and people within a single VLAN will communicate with each other and not having to manage traffic from other networks. At the first part of VLAN, we explain the purpose of VLAN in a switch network, and we even explain how a switch forwards frame based on VLAN configuration in a multi-switch environment. And what we will do in the second part of VLAN will be about configuring a switch port to be assigned to a VLAN based on requirements. We even will configure a trunk port on a LAN switch, and then we will configure dynamic trunking protocol. So as for VLANs, creating is VLANs, which is a matter of entering the appropriate commands. Different Cisco Catalyst switches support various number of VLANs, and this number of supported VLANs is large enough to accommodate the needs of most organizations. Here it is a figure that illustrates the default VLANs on a Cisco Catalyst 2960 switch running Cisco IOS. And you have to know that there are normal range VLANs on the switches and extended range VLANs on the switches. And as for characteristic of each, here it is listed the characteristic of the normal range VLANs, where they are used in a small and medium-sized business and enterprise networks. They are identified by a VLAN ID between 1 and 1005. The IDs from 1002 through 1005, as it is listed here in the example, are reserved for legacy network technologies. These are automatically created and cannot be removed. The configuration are stored in the switch flash memory in the VLAN database, which is called the VLAN.dat. And when configure the VLAN trunking protocol, we'll have to synchronize the VLAN database between switches. And as for the characteristic of the extended range of VLAN, here are listed those characteristics, and they are used by service providers to service multiple customers and by global enterprise large enough to need extended range VLAN ID. And here is the range of these extended range VLANs, their ID. Their configuration are saved by default in the running configuration. They support fewer VLAN features than normal range of VLANs, and they require the DTP transparent mode configuration to support this extended range of VLAN. And when configuring the normal range VLANs, the configuration details are stored in the flash memory on the switch in a file called, as we mentioned, VLAN.dat. Flash memory is persistent and does not require the copy running config to startup config command to save the configuration of VLAN. However, because other details are often configured on a switch at the same time that VLANs are created, it's a good practice to save running configuration changes to the startup configuration. Here it is listed and it is displayed the command syntax used to add a VLAN to a switch and give to this VLAN a name. Naming each VLAN is very important, and it is considered a best practice in switch configuration. So in case you need to configure the VLAN, you have to enter at the global configuration mode, And there, by using the command VLAN followed by the VLAN ID, you are creating a VLAN with that ID. And then you will see that you will be in the VLAN configuration mode, which means that here you can name your VLAN by the command name followed with the VLAN name that you want. And then you have to return to privileged access mode by using the AND command. And here it will be an example where we have this topology that the student computer, which is the PC2, has not been associated with a VLAN yet, but it does have an IP address of 172.17.20.22, which belongs to the VLAN 20. So here it will be the example that show how the student VLAN 20 is configured in the switch 1 here. So first of all, you have to go in the global configuration mode. You create the VLAN 20 by using the command VLAN followed by the ID 20. And then you will enter, with this command, you will enter at the VLAN configuration mode, where you can name your VLAN with the command name followed by the name you want, and by end you are exit to the privileged access mode. After creating a VLAN, the next step is to assign ports to that VLAN. Here in this table, it is displayed the syntax for defining a port to be an access port and assigning it to a proper VLAN. The switch port mode access command is optional, but strongly recommended as a security best practice. With this command, the interface changed to strictly access mode. Access mode indicates that the port belongs to a single VLAN and will not negotiate to become a trunk link. So you have to be at the global configuration mode. You have to go to interface configuration mode by using the interface and the interface ID that you want to assign to a proper VLAN. And then after you will be in the interface configuration mode, you have to set the port to access mode by using the switch port mode access. And then you will assign that port to a VLAN following with the switch port access VLAN with a VLAN ID that you want to assign that port. And then by end, you have to return to privileged access mode. And here will be the example that we mentioned before, where the port F06 on the switch is configured as an access port and assigned to VLAN 20. Any device connected to that port will be associated with the VLAN 20. Therefore, the computer PC2 will be in the VLAN 20. So the commands will be listed here. So we have to be in the global configuration mode with the configure terminal command. And then you have to enter to the proper interface that you want to assign to a VLAN. In this case, we want to go to interface fast Ethernet 06. And then here, after we will be in the interface configuration mode, we will use the switch port mode access, where you indicate that the port will be strictly as an access mode. And then with the switch port access VLAN 20, you are assigning this interface to the VLAN 20, where the VLAN 20 was the VLAN for the student. VLANs are configured on the switch port and not on the end device. So the PC2 is configured with an IPv4 address and the subnet mask that is associated with the VLAN. which is configured on the switchboard. Here in this example, we have the VLAN 20, and the VLAN 20 is configured on other switches. The network administrator must configure the other student computers to be in the same subnet as the PC2. So they have to be at the subnet 172.17.20.0/24. An access port can belong to only one data VLAN at a time. However, a port can also be associated to a voice VLAN. For example, a port connected to an IP phone and an end device would be associated with two VLANs, one for voice and one for data. By considering this topology that we can see in this figure, we have the PC number 5 that is connected to the Cisco IP phone, and then this one is connected with the switch number 3 on the interface fast Ethernet 018. So to implement this configuration, we need to create a data VLAN for the traffic that comes from the PC of the student, and a voice VLAN for the traffic that comes from the IP phone. By using the switch port voice VLAN followed with the VLAN ID in the interface configuration command, we are able to assign a voice VLAN to a port. LAN will support voice traffic, typically also will have quality of service enabled. Voice traffic must be enabled as a trusted as soon as it enters at the network. The configuration in this example for the two VLANs that we said in the slide before is listed here. So we have to create the VLAN 20. We name it the name students. No need to exit from this mode, but because if you say VLAN 150, you automatically are creating another VLAN where you can name this VLAN as voice, which means that it is handling the voice traffic. And then you have to go to the switch interface fast Ethernet 018. With this, by saying the switch port mode access, in this case, you are saying that this port will be in the access mode, and with the switch port access VLAN 20, you are assigning this port to the VLAN 20, which is for data traffic. And by the command MLS quality of service trust, in this case, you are saying that the voice traffic must be labeled as trusted as soon as it enters the network that we mentioned. And this can be done with this command, which means that the voice traffic can be handled through this interface and has the priority of service, which means that it needs to be served first, or this traffic have to be handled first, and then you can say that this switch port voice VLAN followed by VLAN ID, you are saying that this interface will be able to handle even the voice traffic for the VLAN 150. The switch port access VLAN command for the creation of VLAN if it does not already exist on the switch. For example, for the moment we don't have created a VLAN 30, but if you say the switch port access VLAN to 30, you automatically are creating another VLAN that will be VLAN with ID 30, but it is not named. After the VLAN is configured, the VLAN configuration can be validated by using the Cisco iOS show commands. So the show VLAN command displays a list of all configured VLANs. The show VLAN command can be used with options, which means it has a complete syntax by show VLAN followed with other syntax and will give us more information about the VLANs and what kind of information we will need. And here in this table, it is described the show VLAN command with her options. So if it is followed by the brief, it will display VLAN name, status, and its port on VLAN per line. If it is followed as the show VLAN with the ID and VLAN ID, it will display information about the identified VLAN ID number. And if it is followed by the show VLAN name and the VLAN name, it will show information about that VLAN, but in this case, the information, it is searched by the name. And if you say the show VLAN summary, it will display VLAN summary information. And here you can see that we are using a show VLAN summary, and it gives us the number of existing VLANs, VTP VLANs, and extended VLANs. Other useful commands are the show interface, followed with the interface ID and switch port, and the show interface VLAN with the VLAN ID command. And here, in this example, we have used the show interface with the interface ID. In this case, it is for the interface Fast Ethernet 018, where we have created two VLANs, the data VLAN and the voice VLAN. And if we use show interface Fast Ethernet 018 switch followed with the switch port, we will be able to see all the information about the switch port, which means that the switch port is enabled, it has a static access, and there are two VLANs. And this switch port is in access mode for the VLAN 20, and it's able to handle voice traffic for the VLAN 150. There are a number of ways to change a VLAN's port membership. If the switch access port has been incorrectly assigned to a VLAN, then simply re-enter the switch port access VLAN with VLAN ID at the interface configuration command with the correct VLAN ID. So just go to that interface and say switch port access VLAN with the proper VLAN ID, which means that you are sending that port to the appropriate VLAN. Let's assume that we have the Fast Ethernet 018 was incorrectly configured to be on the default VLAN 1 instead of VLAN 20. To change the port to VLAN 20, you just need to be at the interface level of the Fast Ethernet 018 and just enter switch port access VLAN 20, and that automatically will be assigned to that VLAN. To change the membership of a port back to the default VLAN, we have to use the command no switch port access VLAN in the interface configuration mode, which means that this port will be not assigned to a proper VLAN, and then by default it will go to VLAN 1. As you remembered at the first part, we said that the VLAN is automatically created in the switch. It cannot be deleted, and all the ports are by default assigned to this VLAN. And if you will change the membership and you don't want that the membership to be at that VLAN, by using the no switch port access VLAN, the port automatically will be back to the default VLAN. Here it is an example for the fast Ethernet 018, which is configured to be on the default VLAN as configured by the show VLAN command. And you still can see that the VLAN 20 is still active, even there is no port assigned to it. The switch port interface fast Ethernet, the 018 switch port, so the command show interface fast Ethernet 018 switch port here will give us the output where it verifies that the access VLAN for interface fast Ethernet the 018 has been reset to the VLAN 1. As you can see, access mode is for the VLAN 1. Just only the one part of the show interface fast Ethernet 018 switch port. In case you need to delete a VLAN, we use the no VLAN followed with the VLAN ID at the global configuration mode. By using this command, you are able to remove a VLAN from the switch VLAN data file. So by using the no VLAN followed with the VLAN ID at the global configuration mode, you automatically are removing a VLAN from the switch VLAN data file. But before deleting the VLAN, reassign all member ports to a different VLAN first, because any ports that are not moved to an active VLAN are unable to communicate with other hosts after the VLAN is deleted and until they are assigned to an active VLAN. The entire VLAN data file can be deleted by using, at the privileged access mode, the command delete flash VLAN data. The abbreviated command version is delete VLAN data and can be used if the VLAN data file has not been moved from its default location. After issuing this command and reloading the switch, any previously configured VLAN are no longer present. This effectively places the switch into its factory default condition with regard to VLAN's configuration. And here in this slide is a syntax checker activity for VLAN configuration, and based on the specified requirements and the syntax checker. So here we are creating the VLAN 20 and name as a student. Show VLAN brief, it means you will see that the VLAN 20 is created. Now we have to create the VLAN 150 for the VLAN voice, and by using, okay. And now we are to assign the fast Ethernet 018 for the VLAN 20 and VLAN 150, and we have to put that port in access mode for the VLAN 20 and secured for the voice traffic. So here we are doing all the requirements that are specified in the syntax checker. After we are done configuring and verifying VLANs, now it is time to configure and verify VLAN trunks. We explained what a VLAN trunk is. A trunk line is the line that allows the traffic flow from all the VLANs that are configured for that trunk. A VLAN trunk is a layer to link between two switches that carry traffic for all VLANs, unless the allowed VLAN list is restricted manually or dynamically. To enable trunk links, you have to configure the interconnecting ports with the set of interface configuration command as it is shown here in this table. You have to go in the global configuration mode. You have to enter to the interface configuration mode with the interface ID at the proper interface that you need to configure the trunk, and then that port you have to put not at the access mode in this case, but in the mode trunk. With the switchport mode trunk, and then with the switchport trunk native VLAN ID, you are set the native VLAN to something other than VLAN 1. Then, with the switchport trunk allowed VLAN, you will specify the list to be allowed in the trunk link. Then, you have to return to the privileged access mode by using the end command. And here there is an example of trunk configuration. As you can see in the figure, we have VLAN 10, 20, and 30 that supports the VLAN for faculty, students, guests, for computers PC1, PC2, and PC3. The fast Ethernet 01 port at the switch number 2 is configured as a trunk port and will forward traffic for VLAN 10, 20, and 30, and VLAN 99 is configured as the native VLAN. And as the example shows, here will be the configuration on the switch 1 as a port trunk. So we have to enter from the global configuration mode to the interface fast Ethernet 01 with the interface fast Ethernet 01 command. And here in this interface, we will configure that as a mode trunk. We will support traffic for the native VLAN, which will be different from VLAN 1, and it will be VLAN 99. We will, by using the switchport trunk allowed, you are allowing that in this trunk to forward traffic for VLAN 10, 20, 30, and 99. And if you need to verify a trunk configuration in the switch, you have to use the show interface followed by the interface ID and the switch port. And as you can see here, it's all the information, and you can see that the switch port is enabled. The administrative mode different from the switch port fast Ethernet 018. When we checked her, it was in the access mode. Here it will be in the trunk. Operational is in trunk. Now, here it says the protocol that supports for the trunking encapsulation. Trunk in native mode VLAN will be VLAN 99, which is different from VLAN 1. And the trunking VLANs enabled that are allowed to forward traffic, it will be for VLAN 10, 20, 30, and 99. The top highlighted area that are shown here has its administrative mode set to trunk. So the port is in trunking mode. If you need to reset the trunk to the default state, we have to use If you need to reset the trunk to the default state by using the no switchboard trunk allowed VLAN and no switchboard trunk native VLAN, you will be able to remove all allowed VLANs and reset the native VLAN on the trunk. By resetting, it means that the default VLAN, native VLAN, will be VLAN 1. And here it will be shown even here by using the show interface fast Ethernet 01 switchboard. And as you can see, the switchboard is enabled, is in the trunk mode, but it is remove the trunk feature from fast Ethernet 01. As you can see, the trunking VLAN enabled is for all kind of VLANs, and the access mode VLAN 1 for the native VLAN is VLAN 1. In case you will change the fast Ethernet 01 from the trunk mode to access mode, you may go directly in this interface as it is listed here. And by using the switchboard mode access, you are changing her mode from trunk to access. And if you use again the show interface fast Ethernet 01 switchboard, you will be that the switchboard is enabled, same. The administrative mode in this case is static access, and it will be not as a trunk. And if we need to go to the dynamic trunking protocol, is a Cisco proprietary protocol that is automatically enabled on the Catalyst 2960 and Catalyst 3650 series switches. The dynamic trunking protocol manages trunk negotiation only if the port on the neighbor switch is configured in a trunk mode that supports this protocol. Switches from other vendors will not support the dynamic trunking protocol. The default dynamic trunking protocol configuration for these switches is dynamic auto. To enable trunking from a Cisco switch to a device that does not support the dynamic trunking protocol, we use the switchboard mode trunk and switchboard negotiate that is listed here in the interface configuration mode. So by using this, we'll cause the interface to become a trunk, but will not generate dynamic trunking protocol frames. To re-enable dynamic trunking protocol, we use the command switchboard mode dynamic auto as it is listed here. If the ports connecting to switches are configured to ignore all the dynamic trunking protocol advertisements with the switchboard mode trunk and the switchboard negotiate command that are listed here, the ports will stay in trunk port mode. If the connecting ports are set to dynamic auto, they will negotiate a trunk and will stay in the access mode state, creating an inactive trunk lead. For the negotiated interface mode, by using the switchboard mode command with additional options for negotiating the interface mode, you will have the full command syntax as it is listed here. So if you will be in interface with the switchboard mode following with the additional options for negotiation, we will have these options as are described in this table. If you use switchboard mode access, you will put the interface into permanent non-tracking mode and negotiate to convert the link into a non-tracking link. This interface becomes non-tracking interface regardless of whether the neighboring interface is a trunk interface. With the switchboard mode dynamic auto, makes the interface able to convert the link to a trunk link. the interface becomes a trunk interface if the neighboring interface is set to a trunk or the desirable mode. The default switchboard mode for all Ethernet interface is dynamic auto, and we have even dynamic desirable, which will make the interface active attempt to convert the link to a trunk link, and it will become a trunk interface if the neighbor interface is set to trunk, desirable, or dynamic auto mode. And we have even switchboard mode trunk that puts the interface into permanent trunking mode and negotiate to convert the neighbor link into a trunk link. The interface becomes a trunk interface even if the neighboring interface is not a trunk interface. So, depending on this, results for a dynamic trunking protocol configuration are illustrated here in this table, depending on the option on opposite ends of a trunk link connected to the switches. And as you can see, if we have dynamic auto and dynamic auto in both ends, the link will be in access and so on. If you need to verify the dynamic trunking protocol mode, we have to use the command show DTP interface fast Ethernet 01. And by this information, you are able to determine the current DTP mode, dynamic trunking protocol mode, that is shown at the output. A general best practice is to set the interface to trunk and not negotiate when a trunk link is required. On links where trunking is not intended, the DTP, dynamic trunking protocol, should be turned off. And that was all about the second part of the VLANs, and with this we are done with all the information about the VLANs and how to configure those VLANs of VLAN trunk and dynamic trunking protocol. Thank you for being at this channel, and do not forget to subscribe to this channel and hit the notification button for the new videos that will be uploaded. If you like the video, share it with your friends. It will help us grow. Thank you and see you to the next session.